Well, let's solve a problem by factoring. Let's see what we got here. The height of a parallelogram is 18 centimeters less than its base. If the area is 175 square centimeters, what is its height? Let's see, what seems to be important in here? Well, let's see, the height. I see something about the height. I see something about the base. I'm told what the area is, 175 square centimeters. And you know, it always helps sometimes just to kind of sketch something out. It doesn't have to be pretty. Just to kind of give you a visualization of what's going on. So let's see, let's draw a little crude parallelogram, and that's pretty crude. But in a parallelogram, the opposite sides are parallel, and we can find the area. The area is equal to, in this case, they're doing it the height times the base, but sometimes you may see it times the length times the width. In this case, they're substituting height for base. So the height times the base would be the formula that we could use. And let's see, then let's label this as the base, and this is the height of our little parallelogram. Now let's go back to see what they told us. The height is 18 centimeters less than its base. So the height would equal the base minus 18 centimeters. Okay, and the area is 175 centimeters. So we could set this up then as the height, which we now know as B, minus 18 times the base, which is just B, and that equals 175. Now let's distribute the B to the B minus 18, and that would give me B squared minus 18B equals 175. But I'm wanting to solve this quadratic equation, so I'm going to subtract 175 from both sides and get this equation equal to 0. So then we would have B squared minus 18B equals, minus 175 equals 0. Well, now I can factor this quadratic equation. B squared minus 18B minus 175. I'm going to draw a couple of sets of parentheses. And I got just one B squared, so I'm going to put a B in each parentheses. I've got a negative last term and a negative middle term. So this negative last term tells me I got to have a plus and a minus inside my parentheses. And the absolute value of the largest number is going to be negative. And so I'm thinking here, okay, I need two numbers that are going to multiply to 175 and add to negative 18. Well, this 175 is kind of a large number. But let's see. Well, let's see. What if we did 25? What would 25? What other number? If I had a 25, what other number would I need to get to 175? Of course, this is a negative 175. I can't forget that. Well, let's see. 4 times 25 is 100. That means 8 times 25 would be 200, but I got 175, 25 less. So 7. And I got a negative 18, so this needs to be a negative 25. Negative 25 and a positive 7. So I can say positive 7 and negative 25. And that equals 0. All right, well, then we can set each of these factors equal to 0. Now, B is the base. The height, what I want to end up with is I want to figure out the height, which is 18 centimeters less than the base. It's this right here. But let's go ahead and find a value for B. And we're going to set both of these, and we'll go up top with this. So let's see, b plus 7 equals 0. Well, then b would equal negative 7. But b is the base. It's a distance. It's a length. It can't be a negative number. So I can just actually rule this out as a possible solution. But let's continue on. I got b minus 25 equals 0. And now I got b, the base, equals what would be 25 centimeters. Well, now that I have found a value for b that actually is going to work, okay, I go back to what my height is. My height right there is b minus 18 centimeters, so I can say the height is equal to 25, which I'm saying is what the base is, minus 18, and the height then is going to equal 7 centimeters. And maybe I want to check my work. So we said here that we're thinking the height is 7, the base is 25, the area is the height times the base, 7 times 25, shazam, is going to equal 175, and we've solved it. The height is then equal to 7. I love thinking about word problems. They're just so much fun. And the more practice you get, the better off you are, the more proficient you become. Shazam.